Most of us have glimpsed the surface of the Earth from a distance, maybe from a mountaintop or a high vantage point, and saw rivers stretch out and cities shrink into tiny shapes. Higher up, an airplane climbs to around 10 kilometers. From there, the world begins to turn into patterns and shapes. Now imagine going 40 times higher, into orbit. What can astronauts actually see with their own eyes? Or what satellites helps us see even more? And if we could travel farther to the moon or beyond, what parts of our world remain visible? Today, we'll find out together. To understand what we can see from far away, we need to start with a simple idea. Our eyes perceive objects by their appearance, by how much of our visual field they occupy. A familiar example is a pizza about 30 centimeters across. Up close at 1 meter, you see it clearly, full of detail. But if we move it a kilometer away, it shrinks into a tiny dot. Roughly 1 arc minute, which is about the limit of human visual resolution. The moon, on the other hand, spends about 30 arc minutes in the sky. In other words, it appears 30 times larger than our pizza dot. If we scale that pizza up by a factor of 30, it would appear exactly the same size as the moon. And yet the real moon is vastly larger. From our viewpoint, it simply happens to look the same as the enormous pizza at 1 kilometer. And the surprise grows when we include the sun. It also measures about 30 arc minutes in the sky. Even though the sun is nearly 400 times larger than the moon, it's also about 400 times farther away. This balance makes them appear the same size, a rare cosmic alignment and the reason why solar eclipses are possible. Now let's move from our familiar reference to orbit. Here we find the International Space Station, a laboratory and home for astronauts circling the planet. And here the same principle applies. To put this in perspective, 1 arc minute at ISS altitude corresponds to roughly 116 meters on the ground. That is the minimum width of an object to be easily recognizable by the naked eye from orbit. The Great Wall of China, often said to be visible from the moon, is actually difficult to spot even from low Earth orbit. Its width is far below the threshold for naked eye visibility. Cameras with long lenses can capture it, but the human eye struggles. It blends with the surrounding landscape. Some structures have an advantage. The pyramids at Giza, with their geometric shapes along with the high contrast with the desert, makes them easier to spot from orbit. Their height helps too, creating shadows that define their shape under the right lighting. But cities at night are different. Their brightness cuts through darkness, and what you see isn't individual buildings, it's light. The glow of millions of light sources outlining coastlines, highways, and population centers. From the ISS cupola, the view is breathtaking. For example, this photo of Dubai was taken with a zoom lens. On the left, you see the frame exactly as the camera captured it. Tight, clear, and detailed. On the right, we adjust the same area to the equivalent of a 50mm lens. Roughly what the human eye sees from the same place. The difference is clear. The camera highlights Palm Jumeirah with crisp detail, while the eye sees a wider, softer landscape where shapes blend into the coastline. From the ISS, astronauts notice natural patterns far more clearly than human structures. Mountain ranges form long and sharp lines across continents. Deserts appear as bright, expansive regions. Coastlines draw crisp boundaries. Rivers and deltas stretch for hundreds of kilometers. Some natural features stand out even more through color or shape. The Great Barrier Reef draws a turquoise band across the ocean, while the Grand Canyon cuts a deep reddish scar across the landscape, unmistakable even from orbit. Satellites reveal even more. Their cameras can help us see features on Earth as small as 10 meters, about 10 times finer than the human eye from orbit. And what's powerful is not just what's visible now, but what changes over time. Long-term images show cities expanding, rivers shifting, glaciers retreating, coastlines reshaping, and forests changing coverage. From orbit, Earth becomes a time machine, revealing slow transformations that are hard to observe from the ground. And if we left the low Earth orbit and traveled even farther, everything would change even more dramatically. From the Moon, the Earth appears as a bright disk about 2 degrees of arc, almost 4 times wider than the Moon looks from Earth. But from the lunar surface, no human-made structure is visible. And if we journey all the way to Mars, Earth shrinks to a tiny pale dot, a faint star with a hint of color. At those distances, our entire planet reduces to a single point in the darkness. So what can we really see from space? The story of our planet, its shapes, colors, coastlines, and how they change over time. Human structures are tiny details in a world shaped by geology, weather, and life.